coughing, eyes running, itchy nose. Anybody relate? Yeah, you been there, Ronnie?
I've got it.
Yeah. How long did you have it?
For like 2 weeks.
No, don't say that. I've only had it for a day. I can't do that.
I've got it.
Is that an X in the parentheses?
It's almost.
Oh.
Yeah.
Are we learning about that?
Yeah. Okay, mole fraction. Okay. This is one of the few unitless numbers we come across in this class. Okay. So this thing has no units, so this is one of those times you can get away with it. And there's this little X letter, but it's actually not our X, it's a Greek letter. Does anybody know what the Greek letter X is?
Greta.
It's chi.
That's close.
So you can learn that for your Greek fraternities. When you get to college, you'll know some letters. So mole fraction. And basically what it is just a ratio of like how many moles of one thing there is to the total number of moles. Right? So it'd be like saying how many blue M&Ms you have compared to the total number of M&Ms in a package. Or how many orange M&Ms you have to the total number of M&Ms in a package. Okay? So it's the ratio of moles of a component. The ratio of moles of a component in a mixture oh, what are you doing? In a mixture to the total number of moles in the mixture. But it turns out that there's actually some neat things we can do with it. So this has no units. By the way, what did you guys think of the Super Bowl?
Crazy.
I thought that was a good game, man. You know, I mean, it started out so slow, and then it just got better as it went on. And
Only overtime in Super Bowl history.
is that the
right?
first one? I didn't know that, but I knew it was the biggest comeback.
Tom Brady has the most passing yards
Yeah.
in the Super Bowl ever.
Yeah, I heard that on the game. I don't know about you two. I thought Lady Gaga was pretty good.
Yeah, pretty good.
She actually sang it.
Yeah, she
Yeah.
did.
She actually sang it. So
That's crazy. Like coming in on that harness and singing. That's
yeah,
that's
gotta be
hard.
challenging. Yeah, I mean, I'm not like a major fan, but I can respect somebody who can get up there and do that. So I thought it was pretty good Super Bowl.
She's a kook though.
She is good.
Sometimes that's what it takes.
Yeah. Okay, chi then could be expressed like this: n1 over n total. So moles of a component over total moles. That's why there's no units, because the moles are going to cancel away. But here's where the neat thing comes in. We can also relate that to pressure. So this is like a partial pressure. And this is a total pressure. So if that just didn't sink in what I just said, well, basically what I just said this is that it's hard to count particles, isn't it? Right? It's hard to count. You got to go through some gymnastics to do that. You either got to weigh things and really know their weights. Now what I'm saying is, if I have a pressure gauge and I can measure the pressures of some gases, I can tell you how many moles of each gas are there, or at least the ratio of the moles. Do you see what I'm saying? Measuring pressure gets us to now towards counting again.
Which one is that, Charles? That
No, this-
pressure relates to.
Pressure. We don't have one that directly relates pressure in moles,
Oh.
unless you keep. We didn't have one law named that. Now there is a relationship as long as you keep temperature and volume the same, right? So there would be a relationship, but you have to keep the other things fixed. So let's just do example. Say a mixture of H2 gas. Mixture of H2 gas and H2O vapor exert a total pressure of 762 torr. The partial pressure of H2O is 24 torr. Just as a side note there, I've talked to you about these greenhouse gases and stuff like that, and I tell you about CO2 and that that's changing our climate and stuff. Just so you know, water vapor is actually a more potent greenhouse gas than carbon dioxide. You know what the difference is? There's a stuff called rain, okay? And once you get the atmosphere saturated with water, it falls out of the atmosphere. Get what I'm saying? So there, depending on the temperature, there's a maximum amount of water that can be up there. Whereas with CO2, the levels can just keep climbing. You know, there's nothing that's going to cause that to come out to the same degree. So even though water vapor is, you'll hear people say that, well, then we should control water emissions. Well, no, it doesn't work like that, because then they form these things called clouds, and then the clouds rain, and now it's on the ground as snow, and goes into the lakes, and it's not doing the global warming thing, right? So just to be fair. So this thing about, this reason it made me think of that, is if you look here, it says the partial pressure of H2O is 24 torr. You can tell the pressure of water in the atmosphere if you know the temperature.
That's cool.
Okay, and think about it, it's a fairly obvious thing when you think about it like this. This time of year, a lot of people get dry skin, don't they? Cracked, chapped lips. Why?
It's dry.
It's dry. There's not much water in the atmosphere. In the summertime, you walk outside, you feel sticky and slimy and all that. Why? There's a lot of water, and there's a lot of water in the atmosphere. When you want to sweat, you can't sweat that easily, because sweating causes you to evaporate heat. Well, if it's really saturated atmosphere, it's hard for that water to get into the atmosphere because it's already kind of full. All right, so let's say, calculate the mole fraction of H2. What's happening? Of H2 and H2O. Capital T. All right, so let's see. So let's see. P total is equal to 762 torr. H2O is equal to 24 torr. So how could I get P of H2?
Subtract.
Just subtract, yeah. If I subtract those two, I could get 738 torr. So they all got to add up to the total. So now I can get my chi's or my mole fractions. Chi of H2 is going to be 738 torr minus 762 torr. And that equals 0.969. So basically like about 97% of the moles of the particles are H2s. And it's directly related to pressure. And chi of H2O. So again, just for Patrick's benefit, we're calculating something called mole fraction. And it's a ratio of the moles of a component in a mixture to the total moles. And so the easiest way I think about it is, think about how many like blue M&Ms you have in a big package of M&Ms. Count the number of blue M&Ms, divide by the total number of M&Ms. That would be the M&M fraction, right? Blue M&M fraction. So the other thing is that it also relates to pressure. So even though chi is related to moles component over moles total, it's also equal to the partial pressure of a component divided by the total pressure. So you get the same answer either way. And you can do some useful things with this, but right now we're just establishing how do you write it. And so for the mole fraction for H2O would be its 24 torr, what it contributes to the pressure. divided by the total, 762 torr, or 0.031. It's a unitless number, so you get no units here. Yep.
You know, if we're ever confused on anything, can we watch the same videos that Ian watches? Like, are they just on YouTube?
No, what I've been sending Ian, and Ian's been working on some different stuff, and he's not up there yet. But I have resources. That's one thing, let me just say this. I have resources, and if you ever want videos to watch, all you gotta do is ask, right? Just don't wait until 10 o'clock the night before a test, because I probably won't be looking. But I have Ohio State videos that I can give you. The stuff that I have Ian doing was I have him go into a site, and it's still working right now because he's about November right now, okay, and what he's working on. The stuff that we're working on up until then, on this particular site called Science Geek, there's PowerPoints that you watch, and then they have some like tests that you can take that are online like tests, and you can try them over and over again. They could be helpful to you, but I wouldn't just say go do it, you know what I mean, without asking first, because what you find is that in chemistry there's like more. You ever hear there's more than one way to skin a cat? There's more than one way to do a particular process. And you could get into the trouble of, I've showed it you one way all along, and then all of a sudden you're trying to figure out what some guy's trying to show you another way to do it, and then you end up getting thoroughly confused. So I would like to be able to say, hey, this is one that I think will help you because it's along the lines of what I'm doing. So
he's not watching his videos right now.
he's going to get to that because we never started filming this until what? Gosh, just before Christmas or something?
December.
Yeah, just before Christmas. So he's still not to that material. But when he gets to that material, he'll have the videos and he'll have those too. If any of you guys ever wanted access to a lecture that's been filmed, just ask me. I got a link from downstairs, just a YouTube page.
Where do we get 24 for H2O?
Given. Just given in the problem. Yep. In fact, where I would get that from is, and we're going to do a lab like this before too long, where we're going to do something very similar to what we just did here, where you're going to collect a hydrogen sample, but you're going to do it by bubbling that hydrogen through water, which means some water is going to get in the mixture. And we'll know how much water got into that gas mixture by just measuring its temperature. And we can read off a table. So we're actually going to do that.
Does that always have to be given?
Well, you have to have one. You can't just pull them both out of the air. You know what I mean? It's just like anything else. But there can only be one unknown at least.
Okay.
You know, or at least only. There can only be one unknown. Let's just put it that way. Sometimes there's more, but we have ways to get those other unknowns. Okay. All right, so that's it for new stuff today. Okay, let's think about tomorrow. Okay, what I had said before, just to be clear, things that you might want to know is PV equals nRT. You might want to know P1V1 over N1T1 equals P2V2 over N2T2. You want to know molar mass equals dirty P. And the other thing, I guess I didn't write this down, but I've been saying it, is you would want to know 1 ATM equals 760 millimeters of mercury equals 760 millimeters, torr, equals 14.7 PSI equals 101.325 kPa equals 29.9 inches of mercury. I think those are all the ones I gave you. That's all right? Yes, sir.
Could you go over in the equations, like when we know instantly we should use that equation so that we're not confused in which one we use?
Yes. Thank you. This would be for, let's say, current conditions. So if I say the gas has this pressure, volume, and temperature, then you can figure out its moles. Right? If I say this thing has this pressure, volume, and moles, you can figure out its temperature. But if I'm only talking about one gas at a set of current conditions, okay, then I'm talking about the first equation. Second here would be changing conditions. You know, initially a gas has this pressure, and later it has this pressure. initially gas has this temperature, then later it has this temperature. If conditions are changing, then we're going to use the second equation with the ones and the twos. Remember that anything that's not changing can be eliminated. Right? So if you're happening in a rigid container, what could you get rid of?
Volume.
Volume. Right? If I tell you you're at STP, couldn't I tell you that? I guess that's something I should put in here too. STP.
22.8.
TM, and or 273. So, but again, this would be for changing conditions. Two or all could be part of the problem. So it could be at least two of these, up to all. So like two could be like pressure and volume, like a Boyle's law question. You're not gonna have to call it Boyle. I could throw out everything but moles. Like maybe you have a balloon and you change the conditions on the balloon, but you don't let any air get in and out. No moles is constant. I think this one's fairly obvious when you're going to need that one. They're going to say something about density. They're going to say something about molar mass, one or the other, right? And then those are just conversions you'll need. You don't have to write this list of conversions out, but I can guarantee you'll need most every one. You'll probably have to do a conversion of every type. Yes, sir.
What's the name of that number called? The 0.08026.
It's called the universal or ideal gas constant. It's 0.08206 liter atmosphere over Kelvin volt. So, what do you guys want to do at the time? I got here for you to ask questions or whatever.
Can we go over a situation where, like, can you explain a situation when we can take R out and when we
Yes.
need to keep R?
Yes. I don't know how these numbers are going to come out, so I don't know how realistic this will come out being, but I'm just going to make up some numbers. All right, sure, make a question that makes sense. How about I just say it like this? In a container. 20 degrees C. Okay. Okay, now keep in mind, like a little caveat here. I don't know if this is a realistic number that you would get, because I'm just making some stuff up here. But I'm just trying to do one that's a changing set of conditions, where we can throw out R. So if I look at this, first of all, I could get N of H2, which really is, I'm just kind of misleading you right now, okay? And the reason I'm doing that is because 10 grams of H2, well, there's 2 grams per 1 mole. That's 5 moles, okay? But the thing is that this container is sealed. So no gas gets in or out. You follow me? So really it's kind of trying to show you how I could mislead you on something where you don't need it. I keep reading. temperature is at 20 degrees Celsius. Temperature 1 is 20 degrees Celsius, but I better go to 273 right away. So it's 293K. I read on, and it tells me the pressure rises 2. So that's a pressure 2. 32 ATM. And I want to know, and it was heated to 200 degrees Celsius, so I guess I got a T2, 200 degrees C. Was 273. They can go quite in order there. 473K. And I want to know P1.
And volume doesn't matter because it stays the same.
Yeah, because it's like a rich container. So this is one where I throw a lot of numbers at you, but if you start looking at your equation, P1 V1 over N1 T1, oh, P2 V2 over N2 P2.